We present our paper on variational mixture of experts autoencoders for multimodal deep generative models. Here, by multimodal, we consider multimodal pairs that are of comparable complexity that commonly occurs in the natural world, such as images and their captions, video and its accompanying audio, photos and scribbles, etc. This is motivated from a human learning perspective. We understand concepts not just through any single modality, for instance, visual observation, linguistic, description, audio, but from all these modalities combined and how they relate to each other. And the reason we use generative models is because demonstrating thorough understanding of a concept requires being able to visualize, describe, mimic such concept. In other words, the process of comprehension requires flow of information in both ways, from observation to representations, and vice versa. We define the successful learning of such a generative model as the satisfaction of the following four criteria. Number one, latent factorization, in that the latent space should factor into private and shared subspaces of information from different modalities. Number two, joint generation. The model should be able to generate data in different modalities while preserving shared commonality. Three, cross-generation. The model can generate data in one modality conditioned on a different one. Four, synergy. The quality of generation is improved through observing multiple modalities as opposed to observing only its own modality. Methodology. Considering input from M modalities, we can write the lower bound to VAE as follows. Following the practice of importance-weighted autoencoders, we estimate a tighter lower bound by employing a K-sample estimator. To model the joint variational posterior, we propose to factorize it as a mixture of expert of unimodal posteriors. Plugging this in the multimodal importance-weighted autoencoder, we arrive at our final objective. Experiments. We performed experiments on two multimodal datasets. First, we construct a dataset of pairs of MNIST and Street View housing number such that each pair depicts the same digit class. Not only is our model able to perform reconstruction in the same modality, it can also do cross-generation from one modality to another while preserving the underlying digit. It is also capable of performing joint generation, where each latent factor generates the same digit of different modality. To demonstrate our satisfaction of criteria 1, we change the value of latent in each dimension and observe the effect on generation. We can see that the change of some dimensions control the digits in both modalities, some MNIST modality only, and some Street View housing number only. Finally, our results on log likelihoods of reconstruction show that the joint marginal likelihood is always greater or equal to the single marginal likelihood, therefore demonstrating that observing multiple modalities does help with the model's generation. We also show results on the Caltech UCSD birds dataset, where we take text descriptions and images of birds as two modalities. You can see that even with such a complicated dataset, our generated images and captions still correlate with each other in both cross and joint generation. You can find more analysis on this in our paper. Thank you for watching this video.